There have been a number of questions regarding the find and range action and the move toward action and how to get those working. So I'm going to use this little sample project here to walk you through how to get this object to find one of these targets and move toward it. This object here is the enemy, and we're going to have it search for these two objects. So this object needs to have logic on it to perform the searching. Now, searching is a continuous action, and we want this object to only search for one of these targets if it hasn't found one yet. So what we're going to have to do is perform a search, set a property that tells the game there's a target that has been found, and then once we've acquired that target, we need to store what that target is and then have this enemy or this object move toward that target. So here you'll see I have a search rules component that is checking for a property called target searching, and that property is on this entity, and it's just a Boolean. So as long as this value is true, we will continuously perform a search because this is a continuous action. The minute this property target searching turns false, this action will turn off. And we're going to do a random search within a certain range. This is a little large, so we can just search within 2000 pixels. And I've created a object type. Object types are the object mask that exists on spatial components. And these object types are defined inside of settings, engine, and you can define individual, these are essentially tags. Or I could have selected a particular entity, but because I haven't created entities in this scene that are duplicates of each other, these are all separate objects, I created a tag and assigned a tag to each object. So for every object that this action finds in this scene, it is going to trigger this action right here. So it's going to search for one, and then it'll execute all of these actions that I have here. Now I could have put a condition here to check for a certain property or check for a certain value and then execute these actions if I wanted to. But I don't have any condition here. I just have a group action that triggers a number of things. It stops the searching by turning off target searching, setting it to false. I tell the game, hey, I found the target by setting target found to true. And then I store the spatial object that is found. What you'll notice is under find and range, under the find and range action, there are a couple properties that are available. So here we'll see under game current action data. So every action that has custom data available, you'll find it under here, current action data, and this is contextual properties based on which action you are looking at. There is a found entity, which is the actual entity object where you can access components on an entity. There's the found spatial, which is the spatial component that you need to refer to the position of the object that's found. And there's the found spatial's distance. So it'll put the distance value right here of the object that has been found relative to the object that is performing the search. So because the move toward action requires a spatial component in order to move toward it, we're going to store this found spatial component, this property, in a global property called target spatial. Now, because this is an actual game object value that we're storing, we have to make sure to clean this or clear this value, this global value, later on so that there's no memory leak if we were to delete this object. So we can make sure that we remember to do that later on. Now I want to point out that I could have also stored the found entity object. So instead of putting a property on the global object called target spatial, I could have said target entity or target found entity. And I could have stored the actual entity object, which holds all of the components on an entity. And then I could have referred to the spatial object inside of the move toward action by saying the target entity found dot spatial or dot render or whatever I needed to. I could have accessed those different components. But because I only need this one spatial component, I'm just going to store the found spatial on that global property, and I'm going to reference it later on. Okay, so this action will trigger all these other actions, and it will tell the game that I found an object, I'm storing the object, and I want you to stop searching. So this will essentially only execute once, because it's going to, on the first object, it's going to store it and then quit searching. So once the object is found, I have another rules component in here that says I want you to move toward that object that you found. And because it's a random search mode in the find an object range, it's just going to pick one of these targets randomly. And now this target found is going to be true. So this action will continuously execute because target found will continue to be true. If I had set this to true and then set this to false, this action would only execute once. So you have to be careful and make sure that you understand which actions are triggered only once and which actions are triggered continuously, because that's important for how a logic is executed. So this will continuously be true until I turn that off, and move toward action will continuously trigger because it's a continuous action, and it will constantly move the object toward that found target. Now, the move toward action takes a spatial, so the spatial that's being moved, which is this current entity, the spatial on this object, and we need to tell this action what object do you want to move toward. And the best way to do that is to just pass it a spatial component, and it will read the values of where that object is, and it will try to move toward that object at a given speed, given velocity, and it will stop within a certain distance. So if you put 0, it'll move toward that object and land right on top of it. Now, because this is a continuous action that triggers every frame, and I'm passing the spatial component, this action can continuously read the position. So if I were to take this target object and move it around, or if it was an enemy or a character that was moving around in the scene, and this red dot was the enemy, it would constantly follow where this object is moving. It would keep trying to follow it until it arrives at its distance, or until that rule is false, until this target found property turns off the move toward action. So that's the beauty of passing the spatial object, is that it continuously reads the position value and applies a velocity to the object being moved toward another object. Now, because these objects are collision objects, if you were to move this enemy towards this target and they get close enough, they'll actually collide, and there's a physics simulation that's happening. So I don't want that to happen. If I want the enemy to arrive at the target and not actually collide with it, you have to turn this collision spatial into a sensor. Turning a collision spatial into a sensor allows this to receive collision events, but it doesn't actually allow the two objects to simulate or collide with each other. And also I have this object as a kinematic object and not a static object. That's really all there is to it. So if I launch this, you'll see that the enemy is moving towards the object, and it stops right on top of it once it arrives there.